So like really all you guys need to know about depreciation, really. Um, there's just like a few methods of depreciation. Straight line depreciation, straight line, double declining units of activity, also called um, variable change, uh, sum of years, and group slash composite. So like there's certain things to know about this, like for example, like straight line. Um, there's gonna be like a book original cost or the book value, right? And then there's gonna be a salvage value, which is like after the useful life. And they'll calculate the useful life. For example, when you be like, oh, this useful life is 6 years. Okay? Um, so like to calculate, let's say like the original cost was 100,000, and then the salvage value is 10,000. So like on this useful life is 6 years. If you're choosing straight line method, you would get the depreciable base. Depreciable base. So you to get the depreciable base, you get the original cost, the book value, minus the salvage value, to get the depreciable base. Okay, so like the depreciable base is 9,000. Using straight line, all you gotta do is just divide 1 by 6 to get the depreciation rate. So the depreciation rate is 16.67% per year. The thing about straight line, well, pretty much like what would happen is throughout the life of the asset, year 1, year 2, or year 2, year 3, year 4, year 5, year 6, you would be able to calculate. You would calculate the annual depreciation. So that depreciation would be fixed. So like after so like the depreciation, the annual depreciation is 15,000 per year. This is 15,000, and then you would minus that, pretty much, and you would multiply. Well, you would multiply the depreciable base by the depreciable rate for straight line. And then you would to find the book value, you would minus the original book value, the current book value after annual depreciation. And then by the end of at the end of 6 years, pretty much like you would have the book value being the salvage value. At the end of 6 months, the value of the asset would be 10,000, because that's what's the remaining like the salvage value. So like that's how you calculate with straight line. Double declining, you would get the straight line value, or the straight line depreciable rate, multiplying that by 2. So 60.67 times 2, that would be 33%. Is a double declining rate. So it would be 33.34%. But the thing about double declining that's important to know is that after the first year of depreciation, well, the thing is, like, you would actually have like a annual depreciation that changes every year based off the new book value after the deduction of the depreciation, the annual depreciation. So, like for example, the first year, because the original book value is 100,000, you wouldn't even have to use the depreciable base. So 100,000 times 33.4. So you would have like 33,000 be the annual depreciation, right?
1 divided by 2 times 33,000 is 16,500.
Okay. Thank you. So then like now you have like the new book value after that deduction. So like you would have it be 33, 0. So like the new book value is 66660. So then like to calculate the next year's depreciation, you would actually multiply the double declining rate with the new book value. So like each year will be different, pretty much, and after like the new book value will get multiplied again, until eventually the value of the asset is 10,000, as in like the remaining book value. So then like from here on out, there's no more depreciation that's possible. And like if there is a year where like there's some depreciation left, then like you would only that annual depreciation would actually be only the amount of depreciation left to depreciate. If that makes any sense. So like for example, it should be like 5,000, but instead there's only 1,000 left of that able to be depreciated. So then for that year, it will only be 1,000 depreciated, and then the next year will be like 0, for example, because there's no more depreciation that's possible. So like that's double declining. So like unit activity, pretty much there's gonna be like sort of like useful life of the years, but like as well as a calculation. It could be like hours, it could be like certain amount of units of like whatever it's gonna do. So like let's say like 10,000 copies. Alright? So 10,000 copies, so then it's like, oh, how much is it per copy of the original value? I'm pretty sure it's depreciable base. Yeah, so it's like the depreciable base, so like 90,000, let's say, divided by 10,000 copies. So it would be $9 per copy. And like, let's say like for the first year, they only made like 1,000 copies. So then the annual depreciation would be 9,000. So like it really depends on how many copies it's gonna make. For some of years, pretty much, depending on like how many years of useful life, let's say 8. So then like 8, 7, 6, 5, 4, 3, 2, 1, and add these all together, this would be like 36. So 36. So like the first year would be 8, like 8, 5 by 36. So like that's how you calculate the depreciable rate in the first year. It's 22%. 22%. And then by the next year, 7 divided by 36. So like 19%. So like that's how you calculate it with sum of years. And then with group composite, what happens is you guys have to add like for group. It's gonna be calculated the same, but like with group, you're gonna have items that are like very similar. And then but then with composite, you can have items that are like very range, like for different assets, for different asset types. Essentially, you'll have like items A, item B, yeah, like those, for example, like 2 items. So to calculate the group composite, well, really you would need to calculate, for example, just 2 things like the depreciable rate and the composite depreciable rate and composite life, for example. So like to calculate the depreciation rate, you would have to take total annual depreciation, divide that by total cost. So like you have to use straight line to calculate this. So for example, like, let's say if like you have like these 2 items here. Let's say the original value for this is like 70,000. The salvage value for this is like 65,000. So you would have to use straight line. So like this, the depreciable base would be 65,000. And then so like this using the straight line method, let's say 6 years, or like let's say like 4 years. So 4 years, 4 is 25%. So then you can calculate the annual depreciation. Right? So 9,000, 90,000 times 1667. What is it? 15. So, no, what is this percentage? 25% of that is 16. Once you have that, once you get the annual depreciation of all the assets, you just add that together. So like that'll be 31,253. So 31,253, and total costs, like original costs, pretty much. So you just divide that divided by the cost. So 18% would be the annual depreciation, the total the composite depreciation rate. And you could calculate the composite life as well if you would like. You don't necessarily have to, but it'll be like total depreciation cost divided by the annual. So you would have to get the depreciable base. So that's a depreciable amount. 1,000 plus. So that's total depreciation cost divided by the annual total depreciation. So 4.9 years. 4.9 years. Right, in that fraction. So like. So then, like for example, like only specifically for sum of years. When it comes to partial years, like let's say like, unless they tell you to use different conventions, they're like, hey, use the convention of whatever, you know, use the convention of nearest month, use the convention of whatever. If, for example, if it's not sum of years, then like you would just calculate it based off of like how many months. Like first off, you have to figure out like when it comes to these partials, these partial years. You gotta just figure out like, well, most likely you're gonna use the full month. So like, or it could be like half year convention, or like a fraction of the year. Like for example, so you can get this deduction expense really close to what it's supposed to be. Like for example, let's say it's July 7th, right? If it's July 7th, instead of being 6 months, it would actually be 5 months and 2/3, right? You guys see? So like, if it really depends on like what it is. Like you can calculate this as well, really specifically. Um, and get like a really close percentage. Um, I really don't want to do this, but you could technically calculate this with this is probably not really that fun, honestly. This is not fun. So for example, if it was a fractional year, like if they want you to use a fractional for whatever reason, it would be kind of a pain to calculate this, honestly. But you could technically, like if, for example, like some of yours, um, what would happen is pretty much you would say like, oh, well, it would be the first, so 515 times the depreciable cost. So then the annual depreciation should be um, this. That should be the annual depreciation. But because it's only 5, so like let's say, what is that, 62 months, right? Or no, what is that, 12? 2 out of 3 months. Oh, okay. No, so like, gosh, what is that? What's 2 divided by 3? So, yeah, 5.666. So instead of it, alright. Well, let's say how much depreciation would you have per month? You would have $277. $277.777 per month of depreciation. But so like 5 of those months, you would have like 1,388.885 for 5 of those months. But then like for the last month, it's only 2/3, so like 203 times 277.777. So for one of those months, you would only have 2/3 of depreciation. Right? So the actual annual depreciation would be okay, so 15,740.073. So that would be the actual depreciation for that month, right? And then you would minus like the depreciable base with that. So like the book value would be this. You guys see? So like, if you guys were using not the half year convention for whatever reason, like, I'm not gonna use half year convention. I'm gonna use fractional. Then like, yeah, you could get like a really specific number, save like maybe 100. You could save like, depending on like how you scale it, there could be like a huge amount of depreciation possible. But the thing about this is that there is only a prorate, and this prorate is only for the sum of years. So like this is like what you guys need to know about this. Like for everything else, Like it would be like if it was straight line, for example, right? If it was like straight line, 1.5 times, you would see 2,000 depreciation per year. Right? Oh my god, where? Okay. So even there is no prorate, but like there would be like, for example, this year because it's only like it's not half a year, right? So like how much is this? Um, okay. So like for this month, this is really fun. You would see $944.41 depreciation if it was using straight line. So there is no prorate. Like you would just see like in the last 5 years. Let's see, this one's gonna be. That's interesting. Actually, this would probably be. So yeah, this one's kind of tricky because. But I might have to ask my teacher actually.